And it's my pleasure to welcome Srikant Gopi, the founder of Neuroheart AI. He works as a senior prompt engineer in a leading investment bank in the US. His contributions to AI in mindfulness, music, and education have earned him the recognition as the top 30 global trailblazers 2025 at the firm, featured in the Times Square billboards in New York. And this year, he has been honored with the top prompt engineer and AI Innovator of the Year award by the International Association of Top Professionals in Las Vegas. So please give him a round of applause. Thank
you. So the topic is autonomous decision intelligence, bridging KPI diagnostics with agentic workflows in enterprise AI. So first of all, what is KPI? KPI is key performance indicators, as you would know, that helps us monitor and manage the performance of a company as we progress towards certain objectives. The current problem that we face in the industry is the dashboards which we use, the managers use to manage the KPIs are pretty static and based on the dashboards, which are basically vision based, which are very advanced, but it still does not give you any more insights or intelligence on what the data is shown, right? So there the human beings come in and the human being or the manager interprets and then come up with certain kind of changes we need to make the company perform better, right? That's simple enough? Okay. So what happens is that because human beings are managing it, there's a possibility of biases, prejudices, delays, inconsistencies, oversight, and so on, right? And also the manpower required for managing the KPIs, especially in enterprises where there are like thousands of employees, is pretty complex and it's high. I mean, the cost of manpower is high, right? So how can we reduce the cost of the manpower, but at the same time improve the company's performance using AI? So there are three stages of evolution that you all would know. The first one is generative AI. That is basically, as you all would know, ChatGPT, right? So yeah, yesterday I got a notice from ChatGPT that it's 1001 day since I started using ChatGPT. This is a good day to present, 1001 day. And we just ask a question and we get a response. So that is generative AI, basically, LLM response. So in the enterprise, normally it's not chat, it is just a question that we ask and we get a response. So that's like one tone, chat. Right. Second is AI agent, where the same LLM call, we supply it with certain tools to use, or some API endpoints to call to understand what is going on behind the scene, right? Because the LLM is just what it's trained on, it knows. So we supply it with some kind of information and we give some tools, right? Now, Agentic AI, the latest one that we all know, is a team of agents working together with multiple tools, like a team of people with diverse skills, with unique tasks, coming together as a team, using different tools, APIs, agents, sub-agents, and so on. And it has long-term and short-term memories, which we are going to go into deeper. So we are moving into autonomous AI agentic systems, which is adaptive, means it's learning continuously, and it's orchestrating, means it does the self-orchestration of various agents to bring about a certain kind of outcome. Okay. So for this presentation, I did do a project for it. So I pulled down Zara sales analysis dataset, and it's like 470,000 plus transactions in that one single dataset, which you all can download, right? And then I did some analysis to find out how it would work in an agentic system, right? So I have the notebook for this. If anyone of you know who need a Jupyter notebook, you can ask me. Right? So once we feed the agentic orchestrator with the sales data, right, it does some analysis and it chooses which agent to choose. So we have like 5 agents here, right? So this is kind of a simple system. In real life, it's much more complex than this, but I'm just showing a simple system. So we have the agentic orchestrator selecting that I'm going to run these 2 agents in parallel, right, to get some estimation of what's the overall KPI, the revenue, volume, price, and so on. And this is going to segment the data and do some further analysis based on the gender, position, and promotion. So gender means what? It's dress, right? Zara's dress. So does it belong to female, male, or such gender? And the position, which is like where is it placed, right? And promotion is like is it on a discount, sale, clearance, something, right? And then this anomaly detector will detect if there's any kind of drifts away from objectives. Means given limits, is it going above or below, right? So there are 2 kinds of KPIs. One is leading KPIs and one is lagging KPIs, right? So it will show if it's a leading, if it is leading or lagging, or if it's like normal. And then if this pricing optimizer and inventory optimizer is kind of a code only, where it will do some analysis to find out the suggestions like what could we do about it. Then all of these 5 agents, information will go into the synthesizer agent, and the synthesizer agent will do the analysis of all put together, and it can also make some feedback based on the performance, risks involved, and what actions we could take and decisions we could make. Okay. Now there is also a possibility of human in the loop possibility. So here it goes back into the loop, right? So it can actually detect, and if there's a problem, the synthesizer can run the loop again, then suggest a revenue increase of 10%. You can see on the left side here, right? Revenue increase by 10%, sales increase by 30%, and price let's drop by 10%. Then it will go maybe 3 times. Actually, when I ran 3 times to find optimum price and revenue and sales to achieve a certain objective. Okay, is this much clear? Okay. I'll come back to you. You can ask me for more questions. So what if it's a chatbot, right? So nowadays it's all about conversations, right? So it's not just one thing you ask and then you get back, right? There has to be a way to chat with the system. So then we just add a UI where you can enter a query and then you can receive a response, right? Receive a response. Now this will be interacting. This agent synthesizer will communicate with the chat. That is, this is where you have the ChatGPT, a chat. Right? You receive it, and then you have the option to interfere with any kind of decisions or processes or suggestions. Right? So this is basically human in the loop in the system, and then it can go back into optimization process, or it can also be finalized and stored into the memory system. Right? So this system works with 3 memories. So the previous one we had only the vector database, right? How many of you know vector database? Okay, so 4 or 5 people. I need to introduce it. Okay. So here, this one is like short. This is where we call, like, suppose let's say in our computer we store chats. Okay, we have certain kind of interactions with the system, and let's say we store that in an Excel sheet. That is kind of this one, right? So this is basically a SQLite database we can create on local system or on Superbase or MongoDB or whichever database you could use. And this will pull historical chat, text-based, based on your query. Right? This basically ChatGPT also works similar to this. So this one is very clear, right? Short-term memory. Long-term memory is nothing but the cleaned up chat history. Let's say you finish a session. So what the system will do, it will summarize it, clean it up, means it will drop all the stop words, hi, how are you, all of those stuff, and just pick up the key related information to here KPIs, and then store it into the vector database, right? So vectors are nothing but the text information stored as numbers. So next time we have a chat input from the top, we can do a similarity search, we call, where we can find semantically similar content in the database and then pull a top K results, right? So if we search here, what will happen is just like you search on computer, you can search like let's say sales analytics. You can search sales analytics and you can pull the columns like we do in Excel sheet, right? Here, what if there are like 100,000 rows, right? And what if the chat is like a long text paragraph? Then the model will not understand, right? So the memory system, if you do the similarity search, then the vector, which will be matched with the vector of the chat. So let's say the chat we entered 100 words. The system will convert that to a vector, means a set of numbers. And it will search the records in the long-term memory, which is similar to what we're asking. For example, what are the sales performance last 2025, right? So it will select similar records, which is matching with the context of the query. Is it clear? And then it will put same thing here. Here it will be records of the actual dataset. So the Zara sales dataset will be stored in this vector database. Yes.
So is this basically a RAG workflow that you're doing?
Yeah, this is RAG, correct. The retrieval augmented system. So where you match the chat input with, we retrieve the past records, and then we augment it into the system to get the output. So that is a RAG system. So you need to know this in the future because everything is now evolving around this system, right? Now here we give it web search in 2 additional here in this particular chat bar, and then we have a document upload option also where user can upload related documents. So we just did one project like this. So we already have the codes and everything. Yeah.
So these Zara data vectors, are they numerical data or textual data?
Here,
No, this the left.
it's actually one column will be numerical. That's it. The vectors. Vectors means what's a series of numbers.
The vectors represent something else, right? The something else is text or number. They are financial data that are vectorized, or they are textual data vectorized?
Both. It can be 1 word, 100 words, 1,000 words, thousands of pages, right? Not generally one vectors will be set of chunks, means piece segments of text. So let's say we have 100-page text. We may segment it into like 10 parts. Right? That's like details of vector storage. But I think your question is it numbers? Is it storage of financials or text? Yeah, whatever the input is, it will store. So if it's, let's say it's an annual report of a company, it will store the whole annual report in there. And it'll have the tags like 2025 Apple first quarter report, like that. It'll know. Is it clear? Yes, someone else said. Okay. So this is the Zara KPI dataset example. So when we ran the optimization process, actually it did go up, right? So maybe 3 times it ran. So first it ran, made some adjustment, second time it ran, made some adjustment, then it reached the objective. Right? So this is like, you can see on the left here, this is the parameters, right? The parameters, we are playing with 3 here, there could be many more. And we are first we are passing like this much and we're seeing how it is affected, and then we are passing it again. Right? Now there is a very complex memory system also. Where it will be augmented to support the query. Yes.
Could you explain again the overall goal of the KPI example and the model that you built in the previous case?
This one?
Yeah.
See, let's say Zara fixes a price. Let's say we have a set of special kind of jeans, right? And they fix a price of $100. And the sales we expected, we need to sell 1 million pieces, let's say in the US. But it sold only 500,000. So now what to do to increase that sales? Like that. So the memory management system, what it does is, it will augment a set of past records with the chat to the agents, and it will supply to the related agents. So here we saw that like 5 agents shown here, right? Running parallel, sequence, parallel, right? Now each agent will need different set of memory, correct? Because a financial, let's say a person is financial background, right? Needs the financial records like that. So here we are talking about segmentation agent. The pricing optimizer will need the records of past pricing changes that has happened, and it will go through the history to see what happened when we increase the price by 10%, decrease the price by 10%, what happened in that geographical region, what happened in that segment, the gender or the type of dress, something like that. And what if it has 10 years of data, right? Let's say we have a 10-year experienced person who's doing it. The Agentic AI system could be fed with all those 10 years of past records with insights, or as it learns every day, it will keep on learning and improving its own performance. So that is Agentic AI system. That's it.